In this video, we are going to explore the dodSON.Core.Cryptography namespace. Start by creating a console application and adding a reference to the dodSON.Core assembly. Adding this using directive allows us to use extension methods from the dodSON.Core.Cryptography namespace. First, we will explore the salted password. Salting a password refers to adding random data to the password and then hashing it. The resulting hash is stored along with the salt and the hash algorithm type used to perform the hash. The password used to create the hash is contained in a System.Security.SecureString, only used to create the hash and only exposed in memory when creating the hash. Once created, the salted password can be stored and used to verify candidate passwords. We'll start by creating a System.Security.SecureString by using the dodSON.Core.Cryptography SecureString extension append characters. The append characters extension takes a character array and a boolean indicating whether it should clear the incoming character array before returning. We will display the character array before and after to demonstrate that the extension properly clears the character array. We will create a local function to convert the character array to a string. Now we can create our dodSON.Core.Cryptography salted password. It takes a symmetrical hash algorithm type, the secure string, and a salt. To create the salt, we will use the static dodSON.Core.Cryptography helper generate cryptographically random array function to generate a cryptographically random array of bytes. Next, we will display the salted passwords configuration showing that we only store the hash algorithm type, the salt, and the password salt hash. That is the hash generated from the combined password and salt using the given hash algorithm type. Now we will create another salted password with an incorrect password and a salted password with the correct password to compare to the original password. This would simulate getting and verifying passwords from a user. Finally, we will display the comparisons and wait for the user to press any key. Compiling and running the application shows the password character array being properly cleared, the salted passwords configuration, and finally the verification results for the incorrect password and the correct password. Next, we will explore the stacked encryptor and encrypt data using multiple encryption methods at once. First, we will create some text to encrypt and convert that text to a byte array. Next, we will create a stacked encryptor. A stacked encryptor will take any number of encryptor configurations, which it will use one after another to encrypt and decrypt data. The encryptor configuration takes a salted password and a symmetrical algorithm type. We will let the salted password create the salt by creating a cryptographically random byte array of the specified length. Next, we will create a second encryptor configuration. With both of the encryptor configurations added to the stacked encryptor, we will encrypt and decrypt the data. Next, we will compare the results to verify that the encrypted data is encrypted and the decrypted data was successfully decrypted. We will display the results and wait for the user to press any key. Compiling and running the console application shows that the original data was encrypted and decrypted successfully. This demonstrates some of the functionality of the dodSON.Core.Cryptography namespace. Please see the dodSON.Core library help file for more information.